into the practice problems video for the mean value theorem and monotonicity. Okay, for this problem we're going to find a point C satisfying the conclusion of the mean value theorem for the given function f of x is equal to cosine x minus sine x on the closed interval 0 to 2 pi. Okay, so first of all, let's write our all-important equation from the mean value theorem, which is f prime of c is equal to f of b minus f of a, and then all over b minus a, right? So this is the slope of the secant line formed by the endpoints a and b, and then this is the slope of the tangent line at some point c inside our open interval, so from a to b, which in this case is 0 to 2 pi. So a is equal to 0 and b is equal to 2 pi. Okay, and we have our function here. So let's solve for the right side first, the right-hand side. So f of, what we're going to want is f of b, which is now 2 pi, minus f of 0, and then all over 2 pi minus a 0. Okay, so let's solve for this. So we have f of 2 pi, so that's going to be cosine 2 pi minus sine of 2 pi. So that's our f of 2 pi part. And then we're going to subtract away when we plug in a 0 instead. So cosine 0 minus sine 0. Okay? And this is all over a 2 pi minus 0, so that's just 2 pi. Okay? So this is going to be, when we have, let's see here, so this is going to be cosine 2 pi, that's just going to be a 1. And then we have minus sine 2 pi, so that's a 0, so 1 minus 0. And then we have minus cosine of 0 is going to be a 1. And then we have minus sine 0, so that's minus a 0. Okay, and this is all over a 2 pi. Okay? Alright, so now we have a 1 minus 1 on top, so this whole thing turns out to be a 0. So the right-hand side is equal to 0. So now we have is that f prime of c must equal 0. Alright? So again, here's a reminder of f of x. That's going to be cosine x minus sine x. So what we need to do is find f prime of x first. Okay? So what we're going to do is find f prime of x. So that's going to be a negative sine x and then minus a cosine x. Okay? So this is the same thing as saying negative, and then we'll put the rest in parentheses, sine x plus cosine x. Okay? So this is our f prime of x. That was a really weird f. Okay, so anyways, so now what we want to do is just replace the x's with c's in order to get it in as a constant, right? So minus sine c plus cosine c, alright? So now we want this thing to be equal to 0, equivalent to 0, so therefore the right side has to be also equivalent to 0. So when we do that, we get the equation or a negative sine c plus cosine c is equal to 0. So we can just easily divide by that negative 1, divide by negative 1. So we get sine of c plus cosine of c must equal 0. Okay? So then we have that sine c is equal to negative cosine c. Alright? And this happens, let's look at our unit circle. So when we have alright, circle. That looks somewhat circular. Okay, so sine c and so sine and cosine are the same thing except for their opposites directly when we're at this point here. Okay, so this would be at the value when we have a cosine being a negative radical 2 over 2 and sine being a positive radical 2 over 2. So that is at 3 pi over 4. So we have it at c equals 3 pi over 4. Or when we're down here, right? Because then our sine is negative, but our cosine is positive, and we're at 7 pi over 4, or 7 pi over 4, okay? Alright, so we actually found two values that could satisfy the mean value theorem on this interval, so let's write our conclusions on the next slide. So we're going to say that since our f of x, our given f of x, is continuous on the closed interval, on closed interval 0 to 2 pi, there we go, and differentiable on the open interval with the same endpoint, so 0 to 2 pi, there exists, so I'm kind of just stating the mean value theorem, I can't spell exists, hold on, there exists, there we go, exists a value c, such that f prime of that c, f prime of c is equal to f of 2 pi minus f of 0 over 2 pi minus 0, and we found that c could be equal to 3 pi over 4 or c equals 7 pi over 4. Either one would satisfy that. Okay?
I know somewhere we could get away. If you want to find another place, love, disappear and never leave a trace.